These are the Introduction to Acids and Bases notes. You've probably heard a little bit about acids and bases in previous science classes. We are going to kind of focus on, in these notes, just kind of what are some properties of acids, what are some properties of bases, some examples, and we're going to look at acids and bases in equations. We're going to focus on pH during trimester 3. So we're not going to focus on pH until a little bit later. So a review of some of our molecular vocabulary. Remember, an ion is any charged molecule or particle. We could have a charged polyatomic or just maybe a charged atom like hydrogen. If something has a positive charge, that is called a cation. So hydrogen with a positive 1 charge is a cation. An anion is a charged particle or a charged molecule with a negative charge. And so as we are looking at acids and bases and what does something mean, what does it mean if something is acidic or basic, we do need to kind of look at those chemical formulas and we look at how these things behave in a reaction. And one big piece of acids and bases is we discuss a lot hydrogen ions. And so this first question just looks at how many protons, neutrons, and electrons are in a hydrogen H plus 1, and that would be a cation. So as we're looking at this, I gave us a periodic table here. Here's my hydrogen. So just remember that hydrogen is number 1 on the periodic table, and so that means that hydrogen has 1 proton. If hydrogen was neutral, protons which are positive would have 1 negative electron. And neutrons we get by looking at the mass. Hydrogen has a mass of 1. And so our atomic mass is protons plus neutrons. So we already have 1 proton. 1 plus what is going to give us that total of 1? Well, that means that hydrogen would have no neutrons. And so this is for neutral hydrogen. This question, though, is asking, well, what if hydrogen has a positive 1 charge? If hydrogen has a positive 1 charge, that means that we're going to have 1 more proton than we have electron. We can't change our proton. So if we have 1 proton and we have a charge of positive 1, that means that hydrogen with a plus 1 charge is going to have 0 electrons. And so as we look at it, that hydrogen with a plus 1 charge is going to be an atom that has 1 proton, 0 neutrons, and 0 electrons. So what is another word we can use to describe a H plus 1 cation? Well, that H plus 1 can also be described as a proton. So if something is gaining or losing just a proton, there's no neutrons or electrons, that means it is gaining or losing an H plus 1 ion. And so those H plus 1 ions are a big part of what makes something acidic. And so that's something that we can remember back from when we're looking at subatomic particles. All right, so fundamentals of acids and bases. So this unit, we are going to talk about pH again later on. Basics of acids and bases: an acid is going to have a pH of less than 7, and bases have a pH of greater than 7. We don't need to know how we find that right now, but just knowing that less than 7 makes something acidic. If we were going to use litmus paper, which is a way to test pH, blue litmus paper is going to turn red for an acid, and red litmus paper is going to stay red for an acid. Often red is used as a color to represent acids. Acids, if we are looking at their formulas, the formulas generally start with a hydrogen, and an acid is going to donate or it's going to lose a proton or a hydrogen when it is interacting with other things. So those are our fundamentals of acids and bases, or acids. So bases, pH is greater than 7. If we were testing this, if we had blue litmus paper, it would stay blue. But if we had red litmus paper, it would turn blue. For bases, our formula generally ends in an OH. And these both say generally because we're going to look at kind of at the end of these notes what happens if that general rule doesn't work. So generally ending in an OH, which is that hydroxide polyatomic, and bases accept or gain a proton when interacting with a acid. So what are characteristics? So things that are acidic are electrolytes. An electrolyte is something that when dissolved in water, it's going to break up into ions. So a lot of times those are just our ionic compounds. Acids have a sour taste, and they react with metals to form hydrogen gas. So some examples of acids that you may have worked with are vinegar, or might be familiar with. Vinegar, soda, apples, and citrus fruit are all acidic. Things that are bases are also electrolytes, meaning they dissolve in water and break up into ions. Bases have a bitter taste and generally a slippery feel. So examples would be ammonia, lye, which is used in soap and cleaning products, and acids and baking soda. So those are all basic chemicals. So we can have something that is acidic or acid. We can have something that's basic or a base. So what if something is not acidic or basic? What makes a compound neutral? And when we're looking at this, a compound is neutral in terms of its pH, not charge, if one of these two things is true. So if your compound has both a hydrogen ion and a hydroxide ion, that means that it is going to be neutral. If we were to put that hydrogen together with that OH and we do a drop and swap, we get HOH, which we could also write as H2O. So that's why water is neutral. And if something doesn't have an H or an OH, that also makes that compound neutral. Compounds or chemicals that are pH neutral are going to have a pH of 7. And if we were to test that using litmus paper, the blue litmus paper would stay blue, the red litmus paper would stay red. So it's going to test as both a base and as an acid. So examples of things that are basic: water, which we talked about up here because water has H and OH. Water is the only chemical that fits into that top category. All those other ones, if it doesn't have either a hydrogen, it doesn't have a hydrogen and it doesn't have a hydroxide, then any of our other ionic compounds or our ionic salts made with that metal and a nonmetal, or a metal and a different polyatomic than OH, are going to be, or are neutral. So let's practice identifying acids and bases. So determine if the compound is an acid, a base, or neutral. Looking at this first one, that HCl, well, this has an H in it, and so that makes it an acid. Number 2, NaOH. Looking at this one, I see that I have an OH, and so that indication of an OH is that this would be a base. It is basic. HOH, well, if something is an acid, it has that hydrogen. If something is a base, it has that OH. Well, if we have HOH, which has both, having both means that is going to be a pH neutral compound. Feel free to pause the video here and try the rest on your own and come back and check. All right, just to check our answers here. Number 4 has a hydrogen to start, so that is an acid. Barium hydroxide, that OH indicates that that is a base. HBr starts with an H, so that is an acid. When we get to 7 and 8, NaCl, that doesn't have that H or that OH, which means that this is neutral. H2O, well, that's another way we can just write HOH. So H2O is neutral because it has both that hydrogen and that hydroxide ion. As we start to look at reactions and looking at our general chemical reactions, we actually didn't talk about acid-base reactions in our chemical reactions unit. We just referred to those as double displacement reactions because these do behave the same. HCl plus NaOH producing H2O and NaCl, that is a double displacement reaction where those are switching partners. But acid-base reactions are specific types of double displacement reactions where we have an acid and a base, and those react to form only pH neutral products. Because water is neutral because it is that H2O, and a salt or an ionic compound made up of no hydrogen and no hydroxide ions. So as we look at these reactions, so circling our acids in red and circling our bases in blue, acid and base are always going to be on our reactant side. We have water and some ionic compound on the product side, so making two neutral, pH neutral products. So when we're looking at acids and bases in reactions, those have to be on the left on the reactant side. So looking at HCl plus NaOH producing H2O and NaCl, well, my acid is whatever is going to start with that hydrogen. My base is ending with that OH. In number 2, KOH, well, I see that OH, that means this is my base. HBr, starting with that hydrogen, that's my acid. Feel free to pause and try the next two, just identifying our acid and our base. This one, if that HC2H3O2 is looking a little confusing, well, let's look at our KOH. KOH, that has a hydroxide, so that is basic, which means that HC2H3O2 is our acid. And then this final one, HBr, is an acid, and NaOH is our base. So acid-base reactions, if we have a acid that starts with an H, that's great, but that's not always the case. When we looked at those definitions, it said they generally or most often start with an H or end with an OH, but there are acids that don't fit that same criteria, and more specifically, there are bases that don't fit that criteria. And so another way we can define acids and bases are by looking at how that proton, which is a hydrogen ion, how that proton is being shared or passed. And these are called Bronsted-Lowry acids. So an acid-base reaction where one compound passes a proton or a hydrogen to another, this is an acid-base reaction. We can see that HBr is starting with a hydrogen, so we know that that's an acid. This lithium hydroxide is ending with an OH, so we can also see that that's a base. But looking at this definition, our acid is going to lose a hydrogen or a proton. And so if HBr loses a proton, that means it's losing this hydrogen. As we look at our Br, let me compare what's happening with Br on both sides. Well, I have Br here and Br here. That Br had a hydrogen, and after it does not. And so that losing of a hydrogen of that Br means that HBr is an acid. This lithium hydroxide now gaining a hydrogen. We've got our OH is what we look at. So looking at this OH, again, this is double displacement, so those are switching partners. This hydroxide, it does lose the lithium, but looking at that OH, we're also going to have that OH gaining another hydrogen. And so that hydrogen has been gained. So now we have OH and another hydrogen, which makes this lithium hydroxide a base. And here's some more about those definitions. So again, not all acid-base reactions produce that ionic compound salt and water. We looked at those first because they're easier to recognize. And so that definition of an acid-base reaction here, where one compound, which is our acid, is going to pass or donate to another, to determine what is an acid and a base. So your Bronsted-Lowry acid is the thing that's going to lose or donate the proton or the hydrogen. And the thing that gains or accepts the proton or the hydrogen is a base. And again, your acid and base are on the left, and then we're comparing it to what is on the right. So if we look at this NH4, and really we're going to be looking at those H's, I have 4 hydrogens here with that nitrogen. Well, now I have 3 going down, going from 4 hydrogens, and then that chemical with the nitrogen that lost a hydrogen, which means that that NH4 is our acid. This OH, now looking at that, well, 1 oxygen and 1 hydrogen. Now we're going to having 1 hydrogen to 2 hydrogens. The gaining of a hydrogen means that that hydroxide is a base with that. And so again, the acid and base are always your reactants. We're just looking at how is that going to be changing. Is it gaining a proton, or is it donating or losing a proton? All right. So identify which compound is the acid and which is the base. And we might have something that is easy for us to see, but we also might have ones that are less easy for us to identify. So that NaOH plus HBr, as we look at this, let's think in terms of if it's an acid, it is going to give away a hydrogen. Well, we've got our OH and we have our Br. Let's look how those are changing. My OH here, and then my H2O is HOH. So I'm comparing how did those change. That hydroxide here, this gained a hydrogen. So if something is gaining a hydrogen, that means it's going to be a base. And so that NaOH gained, which makes this a base. So then if I'm looking at now my bromine, my Br, that Br is here, that Br is here. Well, Br goes from having a hydrogen to not having a hydrogen in the compound. So that is losing a hydrogen, which means our HBr is an acid. Next one, NO3 minus. And we'll just, you don't need to write reactions with these minuses or these pluses in them. You just have to be able to identify what is your acid term and what is your base term. NO3 with a minus charge plus H2SO4. Which of those is an acid and which is a base? Well, as I'm looking at this, my H2SO4 has a hydrogen. And so I can use that information looking at my SO4. We have 2 hydrogens here. That SO4 now, we're going to have 1 hydrogen paired with it. So by losing a hydrogen, that H2SO4 term is my acid, which means my NO3 minus 1, that should gain a hydrogen. Now my NO3 over here has a hydrogen, and so that is my base. And so our base is that NO3 minus 1. My acid is the H2SO4. HF plus HCO3 minus. Well, both of these have hydrogens, so they both could be the acid, so we need to look at how those pieces change. HF, well, I'm going to look at F and that fluorine and what it's paired with. Here we have 1 hydrogen, and here we have no hydrogen, so going from 1 to 0, this is losing a hydrogen. If we are losing or giving away a hydrogen, that means that that HF is an acid. So let's make sure we have HCO3 minus, we've got our H2CO3 over here. We're going from 1 hydrogen to 2 hydrogens. So that CO3 is gaining a hydrogen, which means that HCO3 is a base. So this definition is a little bit more complicated. It applies even when we have our basic acid and bases, or our simple ones that we can see, but it is what we use when we have something that's maybe more complicated, where we don't have that OH term and that H term as our reactants. Our last piece here now, water is neutral. And so water, H2O, can act as an acid or a base depending on what it is reacting with. So if we have just water by itself, and I say, is water acidic, basic, or neutral? Well, H2O by itself is basic, but is neutral, sorry. In a reaction, water can act as either. It has that H2O, so it can donate a hydrogen, but it can also gain a hydrogen. So if we look at this H2O plus NH3, well, this H2O is losing a hydrogen, which means that by donating or losing a hydrogen, it is an acid in this case. But if we look at this next example, HCl plus H2O, well, this H2O here is going to being an H3O. That HCl is there to donate a hydrogen, which then makes water a base. So water as a chemical is neutral, but it can act as an acid or a base depending on what it is reacting with. So here are some for you to try. These have H2O in some of them for you to practice, and just using that Bronsted-Lowry definition. I'll go through this first one, or maybe these first two. Feel free to pause and just try all of them on your own. So what's the acid and what is the base? So we have HClO2 and H2O. Both of them have hydrogens, so they could both lose or donate a hydrogen. They could also both gain a hydrogen. So let's look at comparing. And I always look at what comes after that hydrogen, that HClO2. Let's look at that ClO2. Here's ClO2. Well, when I look at that, I went from having one hydrogen to no hydrogens. And so by losing a hydrogen, that means that HClO2 lost a hydrogen or donated it, meaning it is an acid. So that means our H2O should be acting as a base. If this is a base, we should be gaining a hydrogen. We went from 2 hydrogens to 3. So gaining a hydrogen, in this case, water is acting as a base. Looking at this next one, HClO plus H2O. Water could be an acid or a base. So we need to be looking at what else is going on. That ClO, this doesn't have a hydrogen, so it's not going to lose a hydrogen. So we can see that we're going from that that ClO minus and then gaining that hydrogen. So gaining a hydrogen, that means that this is a base, and our H2O then should be acting as that acid, being able to donate. So H2O going to OH, we're going from having 2 hydrogens to having 1 hydrogen. So losing a hydrogen or donating, that means that is an acid. Feel free to pause this, try the next on your own, and then come back to look at the answers. All right. So on these, I highlighted my acids in red, my bases in blue, and kind of gave you those same notes I had here. So in number 3, HCl is an acid, H2PO4 acts as a base. And then in number 4, H2S acts as an acid, H2O as a base. And that flips in number 5 to H2S as the acid, as the base, and H2O as the acid, and that's based on what we see happening in our products. There is an Intro to Acid and Bases worksheet posted and a check-in. Please reach out to your teacher with any questions.